Here's a proper nostalgia job then. This is a car radio, probably from the 1960s, and this is for a Daimler, an old classic car. And the owner of this one is kind of keen to get it working again, just to keep everything for the right period of the car. But anyway, we'll have a wee look inside, see if there's anything we can find. Here we are then, and I mean, at least this is a transistor set. A bunch of these early car radios were actually valve based, but they're very early transistors in this. I can tell that these are germanium transistors, so these were the first generation that was really available. Actually, there's a mix. These ones here are all germanium, and then I can see this guy here. These are silicon, and then the power stages on the side here, these are germanium, and these suffered from a problem called tin whiskers, and that's where the case here is made of tin, and there was some growth internal to the case here, and it shorted everything out. So we might find that that's a problem with these transistors here. And then this particular type of casing here, I know, suffered from noise problems. And we've got a bunch of electrolytic capacitors here that are going to be 60 plus years old, so we'll probably need to investigate them. And I do see down in here in the power rail there's something that's kind of burnt going on there. It's maybe just a series choke or something that's had a bit of abuse over time. And the other thing is, this is a positive earth radio. A lot of cars of that generation had positive earth. I think there was some intention that it helped prevent rust. I'm not sure how effective that was, but certainly this was the deal in the day. Now, the owner did comment that before it went completely faulty, the volume control was kind of crackly, and there was some question on whether that might be the problem here. And when I actually zoom in on that, we can see here's our volume control, and the main full level signal is going to be on this red wire, and I can see that the centre tap there, that's actually came off completely now. It was just tacked on and no more when I first looked at this. So I think what we'll do is we'll solder that on, and we'll put some power on this thing, and just see what we get. We might be lucky that that's the issue there. So let's go. Alright, I soldered that cable back onto the volume control, and I've got power applied here, and we can see the backlight is glowing nicely there. And I'm pulling 60 milliamps of 12 volts, so that seems kind of reasonable. There's nothing untoward going on. However, I do see an immediate problem. Let me put my lights on and we'll have a wee look. So I've got these two pair of cables coming out the back here. These are for the loudspeaker, and the white one is connected to the chassis through a choke, so that's really just at the 12 volts, and then the black one's the other loudspeaker connection. And if I put my DMM on there, I'm measuring 6 volts, which is completely wrong. I should have no DC on that whatsoever. That's just going to destroy our loudspeakers. And it's not a sort of residual voltage there. I can put a load on this, and I start drawing lots of current from the power supply, so there's something far wrong there. The interesting thing is that 6 volts is roughly half our supply voltage. And so what I'm hoping is that there's maybe a series capacitor from the power stage here, a DC blocker capacitor, and it's maybe going short. That would give us the half rail kind of problem. It could be we've got a transistor going there, but let's follow this black trace, follow this black wire anyway. We'll follow that through the circuitry and see where it takes us. Okay, so I did actually find series capacitor, the loudspeaker path. This is it here. It measures very well given its age. It's meant to be 500 micro. It measures a little bit high, but the ESR is fine, it's all good. And the date on it is November 1968, so that lets us gauge this thing. And this was a power supply filtering capacitor. Again, measures just perfectly, and the date is 1968, December 1968. So that allows us to put an age on this. You know, it's it's not any earlier than that. So it's a little bit newer than I thought. So given the capacitor's okay, why then are we seeing DC on the loudspeaker? And so I did a search for the transistors that are involved. These are AD161 and 162, so germanium power transistors. And I found some random schematics, so let's have a quick look at that. I found various schematics. This is just a random example of what I found. And what you see is that the bias supply for the two output transistors is then, we've then got a resistor that goes onto the loudspeaker side of that capacitor. So we're passing current down through the loudspeaker. And that seems very alien to me. This is a very, very crude system. But this resistor here is present in our circuit. So this is probably what's happening, and it's maybe a case that the current limit on my power supply, when I put a load on, the current limit just wasn't allowing the thing to operate properly. So I'll go and put these capacitors back in now, the ones we looked at there. We'll put them back in, and we'll revisit this, but I'll increase the current limit threshold on my power supply to see what happens. Right, capacitors are back in then, and I'm connected to a 8 ohm load here, and looking at the voltage across that, and I'm now measuring just under half a volt. And I've increased the current limit on my power supply, so I'm pulling about 160 milliamps, which doesn't seem unreasonable. And this half a volt is, by any kind of modern standards, that's pretty garbage. But it's just the kind of crude circuit technique they've used here. So I've learned something new there. I've never seen this approach before. So I think the next thing we'll do is I'm going to just connect this to the scope, and we'll look to see if there's any audio life on that. I'm not quite keen to connect this to my loudspeakers just yet. So let's hook up the scope and see what we see. We're connected to the scope here then, and you can see some garbage waveform on the screen. Most of that's just pickup. But when I tune the radio, it has absolutely no effect. I'm expecting to see something bursting into higher level there, and I just get nothing. And if I turn the radio off, and that's at full volume, I had it. Turn the radio off, I still get this kind of signature here. So that's just pickup of some form. And the other thing I tried, let me just change my scope configuration. So we saw there that there was no effect on tuning the radio, and what I've got here is just a normal scope probe plugged in, and I've got the earth of the scope probe connected to the tip. So I've got a little loop antenna in there, and I've turned up the gain on my scope there. I'm 10 millivolts per division, and when I sort of put my probe in there, put that little loop antenna in there, I'm expecting to pick up the local oscillator in the radio to some degree, and I'm getting absolutely nothing. So it strikes me that the radio portion here is not working at all, and that might be down to these germanium transistors that we spoke about before with the tin whisker problem. So I think what I'll do now is we'll go back and revisit that volume control, and what I'll do is I'll actually apply audio to that, and then we'll check the amplifier side. We'll get some life out of that, and then we'll maybe go and revisit these transistors. We'll maybe take them out and measure them, see how they're behaving, and go from there. Right, so I've just connected the function generator from the scope into the volume control there, as if it was coming from the radio. And if I turn up my volume now, then I can see I've got a signal. And it's very noisy and jumpy. And this is consistent with what the owner said about the volume control being noisy. So that clearly needs a clean. And whether that's possible or not, I'm not entirely sure at this stage. It might have to come apart to do that. But what it tells us here is our amplifier is working just fine. That I'm getting sort of 8 volts peak to peak there before I run out of steam. So that's working just perfectly. So there's something wrong with the radio side then, and we also saw that I couldn't detect any local oscillator. So we'll go and investigate those germanium transistors on the input side and see if we can find any problems there. Here's a page I've found from Vintage Radio.com, and it talks about these 117 transistors being by far the most unreliable. And it goes on to talk about the mechanism of failure and the like. But basically we've got our transistor, we've got our usual three terminals, emitter, base and collector. And then with these guys there's an additional shield pin, and that should simply only connect to the metal can. And what happens is over time we see the growth of what's been labelled as tin whiskers, these kind of fine hairs that are growing inside the can, and they start to short out your normal transistor terminals to the can, and so it basically fails. So if we go and measure a transistor, what we expect to find is that if we measure between the shield and all the other pins, we should have an open circuit. And you know, any kind of resistance that we see there is an indicator of this problem, and then we have to try and deal with it either by replacement transistors, which is very difficult to do nowadays, or there's some other tricks we can play. So let's go and measure some of our transistors and see how we go on. So I took one of these transistors out and it measured okay. This is the second one. And if I measure to the shield from the case, that's reading 0.3 ohms there, that's fine. All other pins should read to open circuit. If I measure the collector here, I'm measuring just 39 something ohms. That's wrong. That tells me there's some growth in this transistor. And if we look at the other terminals, there's my base and I'm getting a couple hundred ohms. And again, that's just not on. And the emitter, what's that? Yeah, some k ohms to the emitter. So this transistor definitely is suffering from our tin whiskers, and ideally it would be good if we had a modern replacement for this, but we don't. And there is a little trick we can do. What we try and do is we burn off these internal whiskers by giving them a jolt of current. And what we'll do is we'll use a capacitor. We'll charge up a capacitor and then connect it between the shield, and we'll join all the other pins together. And we then discharge the capacitor through this thing, and hopefully we can burn off these whiskers. So let's set that up and see how we go. I've never done this before, so this will be interesting to do. What we should find after doing that is that we then get an open circuit between all these pins again. So let's try that. Alright, so here we are. I've got a 1000 microfarad capacitor here, 50 volts, and it's connected to a 50 volt supply. So that's fully charged up. And I've got one side of my transistor, the emitter base collector's connected to one side of that guy. And what we're going to do is discharge this capacitor through the shield pin and hopefully burn off these tin whiskers. And if I just show, I'm just going to short out the capacitor here right now. That spark that we see there, that's what we want to happen to a lesser extent inside the enclosure of this transistor. So let's just do that. I'll just pull this pin over, and you know, we're not getting any reaction there because everything that's happening should be going on inside the case, but I'm just doing that a few times there. I'm going to measure the resistance of this thing now, see if we get an open circuit between the emitter base collector and the shield pin. Right, so here we are, and our emitter base collectors all joined together, and we saw the lowest point I think was to the collector before, and it read 30 something ohms. Now if I measure between all three terminals in the shield, I'm reading megohms of essentially. It's because I'm touching the case here, I'm actually reading open circuit completely. So that technique has worked there. We've managed to burn off these whiskers. And there's a second part that we want to do here. What we'll do is we'll connect the capacitor permanently, and then we want to bash the transistor a bit so that any kind of loose whiskers inside that are kind of just making or the like or just not making. We'll kind of dislodge them a little bit, and if there's anything there we'll burn them off as well. So let's just do that. Alright, so I've now got a permanent connection there, and there's no current flowing through this thing, but if we kind of just give it a bit of a hard time there, then anything that was kind of just not making it inside that can, hopefully we've kind of dislodged it and burnt that off also. So we'll clean this up now, we'll test it as a transistor, and then we'll put it back in the radio. So here's our transistor after its treatment there, and if we measure it as a transistor, just look at the base emitter junction. I'm reading okay there at 0.3 volts, that's good, and then the base collector junction 0.2 volts, so that's healthy for a germanium transistor. And if I go back and measure my DC resistance again, then I'm measuring open circuit between all the pins in the chassis other than the shield pin, which is a short. So that transistor's, the treatment's worked very well, quite pleased with that. So we'll put that in, and I'll go through the same procedure with the other two transistors and see what result that gives us. Alright, so I've given all of these transistors their medicine, if you like, and they're all back in place there. And I've found a point I can probe here just to measure the local oscillator in the radio. So that's us at the top end of the medium wave band there, and we're measuring just over 2 megahertz, which is what we expect. And if you can see the frequency changing as I adjust the tuning on the radio all the way up to a megahertz at the other end. So that's working just perfect now. Very happy with that. A good result with these transistors. And I've got a loudspeaker connected there, so I need to go and turn off some of this equipment. It's too electrically noisy really to allow a radio like this to work. So we'll turn some of that off, we'll kind of patch up an antenna and see what we can find. Here we are with the speaker set up then, and if I just got my metal tweezers here and holding it with my finger acts as a bit of an antenna. So if I just probe on that.
Porcini, ricotta and the League One side, fierce attack of the game, they get down.
Yep, said studio foil.
So we've got a result there. I mean, I've obviously still got computers and stuff running here, so it's still quite electrically noisy. But obviously we're working quite well. So I'm going to take apart that volume control now, or have a look at it at least and see if we can clean that up. I mean, actually when I operate it here, it's not too bad. It's hard to detect a problem, so I'll maybe even just give it a squirt of contact cleaner. We'll see how that goes. But
more 60s covers then. Japan on Get It On.
so here's our volume control removed, and I suppose the obvious thing is to try and squirt some contact cleaner in these gaps and spin the thing around a little bit. What I find though with that kind of approach is that it just shuffles the dust around. Really, it doesn't get rid of it. Really, the only approach is to take it apart. So I'm going to try. I'll try and take this first section apart, and we'll see how that goes. If it's proven difficult though, or I'm in any way of risk of kind of damaging this thing, then I'm just going to stop and we'll live with it as is. Getting a replacement for this would be near impossible, so we'll be kind of careful. But what we'll do is we'll bend up these lugs and see what access we've got to the first section. And then this is a 2-section pot. First section's for the tone control, and then the other one's the volume, and we've all got the on-off switch as well. So we'll bend these up, see how we go on. I mean, that came apart quite straightforward like. And we can see the garbage on the contacts there, so I'll just go around and clean these with a cotton bud and some contact cleaner. I'll maybe buff up these brass parts just using the sort of abrasive stone, and that should be good for a while. So let's go ahead and do that. So here's cleaned up very well. I've got some very thin contact oil here, and just put a wee dab on these contacts, and we'll assemble this thing back together. Hopefully it goes back together as easily as it came apart, then we'll be in good shape. So that's all back together just fine. Quite happy with that then. And that's, that's a proper way to clean these things. As I say, squirting contact cleaner in there doesn't really do the right job. You can see the dirt on my cotton buds there. So all of that, if you just use contact cleaner, all of that garbage is still in there floating around. So this should be nice and smooth operation now. So let's install that back in the radio, and then I think we're nearly ready to be wrapping this one up. Here's our little car radio all complete, and not a hi-fi project this one, but it's been interesting to look at those old style transistors and being able to bring them back to life. And we saw when we were inside, we saw all the different coils and variable capacitors and things like that, and it would have been nice to tweak these up to perfection, but without the radio procedure would likely do more damage than good, so it's probably best left alone. I couldn't find any documentation in this particular radio, so that's where we are, but it's all working just fine now, so let's just power it up and see what we've got.
Myself as a league official, not as a referee. I was assaulted myself.
Who's the only other English, don't say it in case you know, it's easy, we don't say it, only other English #1 goalkeeper to have won the Premier League? Answers that and more coming up after this. On Drive.
Talk Sport Drive with Motorpoint. Buy a Tesla for less with low APR.